Number one, an athlete has mass m kilograms. The athlete runs along a horizontal road against a constant resistance force of magnitude 24 newtons. The total work done by the athlete in increasing his speed from 5 meters per second becomes 6 meters per second, while running a distance of 50 meters is 1,541 joules. Find the value of m. First, I would like to find the change in kinetic energy because he runs, this athlete. So the change kinetic energy equal 1/2 and v squared minus 1/2 and u squared. U is initial velocity and v is the final velocity, right? So the initial velocity is 1/5 and the final velocity is 1 because his speed increasing from 5 becomes 6. And we can simplify this, this expression becomes 1/2 m v squared minus u squared. This, or 1/2 m times 6 squared minus 5 squared. So it's going to be 1/2 m times 11 because 36 minus 25. So it is 5.5 m. And the next step, I'd like to find the work done. The work done equal the change kinetic energy plus work against resistance. Okay. Work done according to this information is 1,541 plus this is change of kinetic energy 5.5 plus work against resistance is Fr times S. This is the resistance force 24. Okay. M supposed to be M here. Okay. So the resistance force, according to this information, is 24. Okay. And time S, according to this information, S is distance is this one, 50 meters. And it becomes 5.5 m plus, if we calculate this, is 1,200. Okay, so m, we can find m equal 341 because 1,541 minus 1,200, 341 over 5.5. And the result is 62.0 kilograms. So this is M. Next question. Look at this diagram. Coplanar forces of magnitude 60 newtons, one, 12 newtons, one, 24 newtons, and 8 newtons acting at a point in the direction shown in the diagram, this diagram. Find the magnitude and the direction. So we're going to find the magnitude and directions of the single additional force acting at the same point, which will produce equilibrium, right? So there are 4 forces acting on this diagram. First, I would like to show you the components on this diagram. So I have created becomes the triangle, the right angle triangle like this. This is the right angle triangle representative of this right angle triangle. Okay, this is 30, and according to the information, this is 12. And if this is x because on x-axis here, and this is y because on y-axis here. Okay, so sine 30 equal x over 12. So it means x, component x equal 12 times sine 30. And cosine 30 equal y over 12. So y equal 12 sine 12 cosine 30. So there are components here. This is the component of, according to this information, 12 cosine 30. And after that, this on x-axis, there is a 12 sine 30. Now for this force, okay, I would like to create the right angle triangle representative of this right angle triangle. This is 30, and this is y, this is x. And according to this information, this is 8. So sine 30 equal y over 8. So y equal 8 sine 30. And with the same process with this one, so x equal 8 cosine 30. Now this one, this is a right angle triangle here. So I'd like to create the right angle triangle here. Okay, 16. This is y. This is x. So cosine x, cosine 30, I mean, equal, this is 30. Cosine 30 is x over 16. So x equal 16 cosine 30. The same process as 1. We can state that y equal 16 sine 30. Now we're going to find, wait, I would like to here the forces based on this information. This is 8 sine 30, and here is 8 cosine on x-axis, x cosine 30. And according to this information, here is on y-axis 16 sine 30, and here is according to information 16 cosine 30. Okay. Now we're going to find the forces acting on x-axis and y-axis. So on x-axis, Fx, if you look this diagram, there is 24 here, or 24 newtons. Okay, and after that, plus one, 12 sine or 8 cosine, 8 cosine 30, okay, and as well 12 sine 30, and after that this. Okay, so forces acting on x-axis, uh, opposite with this forces, so it means minus 16 cosine 30. All right, cosine 30, square root 3 half, and sine 30 is 1 half. We need this information. Substituting this information, so that 4, this is 8 times 3 half, 12 times 1 half, 16 times square root 3 half. So it becomes 24 plus 4 square root 3, 6, 8 square root 3. So it becomes 24 plus 6, 30. 4 minus 8 minus 4 square root 3. So this is the force acting on the x-axis. Now force acting on y-axis. There are two forces here and one two upwards. That means Fy. Y 8 sine 30 plus, oh yeah, the direction to the right side, to the right, or to the positive side. And this is 16 sine 30 minus, if you look this diagram, 16 and 8, and to upwards is 12 cosine 30 minus 12 cosine 30. Now substitute this information, cosine 30 and sine 30, comes 8 times sine 30 1 half, so 16 times 1 half as well, minus 12 cosine 30 square root 3 half. When we calculate, it becomes, it is 4 plus 8 minus 6 square root 3. So this is 12 minus 6 square root 3, and the direction to downwards. Okay. After that, we're gonna find the total force. If I'm going to create here. Okay. Based on this information, on x-axis, this is the force is on to the right. Okay. Okay, to the right. 30 minus 4 square root 3. And after that, to downwards in front. Okay, this is Fy, 12 minus 6 square root 30. So we are going to find the total F, the resultant F, this one, using the Pythagoras rule that 30 minus 4 square root 3 squared plus 12 minus 6 square root 3 squared. Okay. So if you calculate it is 532.307 on plus this one is 2.584 on, and after that, if you calculate this, it's 534 23.8924 on, and the result is 23.1277 on. Round off becomes 23.13. So, after that, we're going to find this is theta here. Okay, so tangent theta equal Fy over Fx. This is Fy, this is Fx. It becomes 12 minus 6 square root 3 over 30 minus 4 square root 3. Or this number, 2.584 on divided by 532.3078 on. And the result is 0.0696 ounce. So theta equal tangent power minus 1 of 0.06968 on, and the result is 3.9861 or 3.99. So this is theta. Number 3, a car of mass 1,600 kilograms travels up a slope incline at an angle of sine power minus 1, 0.08, or arc sine 0.08 to the horizontal. There is a constant resistance of magnitude 240 newtons acting on the car. It is given that the car travels at a constant speed of 32 meters per second. Find the power of the engine of the car. According to this information that the constant speed, 32 meters per second, constant speed, it means the car has not the accelerations. So we can state that acceleration on this case is 0. Now I would like to sketch the car condition theta, and this is car. So there are several forces acting on this car. First, I'm gonna write this as F1, and the second is this is F2, and also according to this information there is constant resistance of magnitude acting on this car. To downwards is 240. And after that, this is, of course, weight or m times g. So now, I'm going to find F2, that F2, based on this information, this condition that 1,600 is the mass times the gravitational force 10, and sine theta, okay, 0.08 based on. So actually this is sine theta, okay, and the result if you calculate is 1,280. So this is F2. Next, we're gonna find that m times a mass times acceleration equal F1, okay, forces acting on this car to upwards and downwards, okay, minus 240 plus F2 plus 1,280. So as you know that acceleration equals 0, so this is 0, and F1 minus, if you calculate this, 1,520. So we can find F1 equal 1,520. Fine. Okay. Now we're gonna find power. Based on the formula that to find power, we're gonna using this formula that F equal power over the speed is. So I would like to rearrange this formula becomes power equal F times speed. So F is 1,520, and speed is 32 according to the information. And if you calculate, the result is 48,640 watts. So this is power. Next question. Find the accelerations of the car when its speed is 24 meters per second and the engine working at 95% of the power found. According to this information that the speed is 24 meters per second, this one, and the efficiency is 95%. It means power on this case becomes 0.95 because this is 0.95. Okay, 95 divided by 100 times the previous power, 48,640. And the result is 46,208. Now we're going to find F, of course. Now F equal power divided by velocity. So 46,208 divided by velocity 24. For speed, it is 1,925.333 so on. And the next is I would like to using formula that M times A, like on the previous part on part A, it equal F minus a 240 plus F2, or F minus 140 minus F2. It becomes mass is 1,600 times A. Okay, F is 1,925.333 so on, and minus 240 plus 1,280. So it becomes, this is 1,608. If you calculate this, is 405.333 so on. So it means A, if you calculate divided this number divided by this number, the result is 0.2533 on meter per second squared. Next question, number 4. Two particles A and B of mass 3 kilograms and 6 kilograms respectively lie on a smooth horizontal plane. Initially, B is at rest and A is moving towards B with speed 8 meters per second. After A and B collide, A moves with speed 2 meters per second. Find the greater of the two possible total losses of kinetic energy due to the collision. So first, B at rest and A moving to B with the speed 8 meters per second. And after collision, so the A speed becomes 2 meters per second. So 8 meters per second becomes 2 meters per second after collision. I will using the formula of conservation of momentum, that ma times initial velocity of A plus mb times initial velocity of B times equal ma times the velocity after collision plus mb and the velocity of B after collision. Right. ma times UA, MA is 3, and based on the information that this is 8, MB is 6, and initial velocity is 0, okay, because at rest, and MA is 3, and the velocity after collision is 2, this one, and MB is 6, and the velocity after collision we are going to find B. Okay, so it is 24 equals 6 plus 6 VB. So it means 6 VB equal 18 because 24 minus 6. So the velocity of B after collision is 3 meters per second. 18 divided by 6. Now, initial kinetic energy. It is 1/2 ma mass of A times the initial velocity of A squared plus 1/2 of mass of B times the initial velocity of B squared. This is 1/2. This is 3. This is 8 plus 1/2 6 0 squared. Okay. So if you calculate the result, this is 0, and this one is 96 joule. Wait. Okay. Next. The final kinetic energy. Final kinetic energy. This is 1/2 ma VA. This is the velocity after collision. 1/2 mb VB. Okay, after collision. 1/2 times 3 is 2 squared. 1/2 times 6. Okay, since 1. And VB is 3 based on this information squared. And if you calculate this is 6 plus, because 4 divided by 2 together, so 6, and this is 9 times 3, 27. So it is 33 joule. And the next step, we're going to calculate the energy loss. Energy loss, or delta E, is kinetic energy, the initial kinetic energy minus the final kinetic energy. 96 joule minus 133 joule, and the result is 63 joule. So number 5. A particle of mass 12 kilograms is going to be pulled across a rough horizontal plane by a light inextensible string. The string is at an angle of 30 degrees above the plane and has tension Tn. Look at this diagram. The coefficient of friction between the particle and the plane is 0.5. So mu equals 0.5. Given that the particle is on the point of moving, find the value of t. So there are several uh, components here. The first here, so I would like to, this one if this is y and this is x, so sine 30 equal y over t because this is t according to this information. So it means y equal t sine 30. So there is component t sine 30 here and also component r here. And for on this axis, for this axis x, so cosine 30 equal x over t, so it means x equal t cosine 30. So there's a component here, this is t cosine 30. And after that, a component to there to the left side, and this component I would like to tell is f. And to downwards, of course, this is m times g. M times g, 12 kilograms times 10, 120 newtons. Okay. Now, on y-axis, first on y-axis, look that r, okay, on y-axis is, on this axis, r plus t sine 30, sorry, t sine 30, I fix first, t sine 30 equal 120. Sine 30 is 1/2, so it becomes r plus 1/2 t equal 120. Next, f equal mu times r, and it is 0.5 because mu is 0.5 according to this information. Hold on first. 0.5 times r is this one. Wait. R is 120 minus 1/2 t. Okay, 120 minus 1/2 t. Fine. So after that, I would like to find the total F or total force or M times A equal T cosine 30 minus R. A is 0, so 12 times 0 equal T times, this is square root 3/2 minus 60. Yeah, this is 60 and this is 1/4 t. This is 60 minus 1/4 t. And it is 0. So go 3/2 t minus 60 plus 1/4 t. So go 3/2 t plus 1/4 t equals 60. Find t. So this is square root 3/2 plus 1/4 equal 1.1160, so on. T was 60. So t equal 60 over this number 1.1160 on. And the result is 53.76 so on. Round off becomes 53.8, of course, newtons. Sorry. A question. Given instead that the particle is accelerating 0.2 meter per second, find the value of t. So according to this information that a equals 0.2, we're going to using the previous accelerations on part A, that m times a equal t cosine 30 minus r. So m is 12 and a, according to this information, 0.2 times square root 3 half t. Okay, because this square root 3, square root 3 half cosine 30 minus 60 minus 1 quarter t. If you calculate this is 2.4 and square root 3 half plus so t, I mean t plus 1 quarter t minus 60. This is 1.116025 so on t 60. So it becomes 1.116025 so on t equal 60 plus 2.4, 62.4. So t equal this number divided by this number. And the result is 55.912. So t round off becomes 55.9. So this is the result. Number 6. A particle moves in a straight line. It starts from rest at time t equals 0 and accelerates at 0.6 t meter per second squared for 4 seconds, reaching a speed of v meter per second. The particle then travels at v meter per second for 11 seconds and finally slows down with constant acceleration, stopping after a further 5 seconds. Show that velocity equal 4.8. Right. They are going to find the velocity after 4 seconds. And the acceleration function through this information is this one, 0.6 t. So at equals 0.6 t. And to find the velocity, we are going to find the integral of acceleration, 0.6 t dt. So it is 0.3 t squared because 0.6 divided by 2 equals 0.6 plus c. And according to this information that the particles start at t equal 0. So it means when phi equals, when phi 0, when t equals 0, when t equals 0, phi, the velocity is 0. So it means 0.3 times 0 squared plus c equals 0. So it means c equals 0. So this function, the velocity function becomes 0.3 t squared plus 0. So the function is 0.3 t squared. This is the velocity function. And when t equal 4, phi 4, it is 0.3 0.3 times 4 squared. So 0.3 times 16 is 4.8, this one. Next question. Sketch a velocity times graph for the motion. Okay, so at the first, the particle moves from t equals 0 to t equals 4 as long as 4 seconds. And the velocity function is 0.3 t squared. So I would like to sketch here. Okay. That is x-axis, this is y-axis. So from t equals 0 to t equals 4, if 4 around here, so 4.8 around here, okay? So it's going to be here. Because this is the quadratic function. So this is 4.8 and this is 4. Okay, when t equal 4, y equal 4.8. This is, it means, sorry, this is t. This is t-axis. And this is vt axis. Okay, right. So this is as long as 4 seconds after that. So that the speed v meters per second, and the particle travels for 11 seconds. For 11 seconds, it means 4 plus 11 or 15. So 15, 15 here. So it is straight line 15. Okay. 11 seconds, and after that, and finally slows down with constant deceleration stopping after 5 seconds. After 5 seconds, it means 5:20 becomes 20 around here and slows down. It is straight line. Right. So this is the graph. Next question. Find an expression in terms of t for the velocity of the particle for 15 to 20. 15 to 20, it means as long as this part. Okay, when this coordinate point is 15, 4.8, and this coordinate point is 20, 0. Okay. At first, I would like to find because this expression, I would like to find uh, the gradient m. The gradient is if the straight line through, wait, I'm gonna check. Yeah, 15. Sorry, 15, 4.8 and 20, 0. Yeah. So it could be 4.8 minus 0, 4.8 minus 0 over 15 minus 20. So it becomes 4.8 over minus 5, and it is minus 0.96. And a straight line through 20, 0 and with gradient minus 0.96, I would like to using this formula for straight line. Okay, so y minus y1 is 0, and m is 1 minus 0.96, x is t, and x1 is 20. This. So y equal minus 0.96 t, plus 19.2. So the function is 54 minus 0.960 plus 19.2. Next question. Find the total distance traveled by the particle. Okay. If you look the graph like this, okay, so this is 4, this is 15, this is 20. So first, we're going to find this area. Area 1, so integral, this is 0, 0 to 4 of 0.3t squared dt. So it is 0.4. The integral is 0.3 divided by 3, so 0.1 t cubed. This one, substitute 4 and 0. And it's going to be 0.1 times 4 cubed minus 0.1 times 0 cubed. And it is 0.1 times 64, 6.4. This one. And the next area, when I'm using different color, this one, this the second area, rectangle. Okay. And the rectangle area this is 11 and this is 4.8 because 4.8 here. So 4.8 times 11, it is 52.8. And the third is this one, triangle. So area 3, a right angle triangle, as this is 5 and this is 4.8. So 1/2 times 4.8 times 5 is 1/2 times 24. It is 12. So the total area equal 6.4 plus 52.8 plus 12, 71.2 meters. This is the total area. Number 7. Look this diagram. Two particles A and B of masses 3 kilograms and 5 kilograms respectively are connected by a like inextensible string that passes over a fixed smooth poly. The particles are held with the string taut and its tripart vertical. Particle A is 1 meter above a horizontal plane and particle B is 2 meters, this particle B and particle A, above the plane. See the diagram. The particles are released from rest in the subsequent motion. A does not reach the poly, and after B reaches the plane, it remains in contact with the plane. Find the tension in the string and the time taken for B to reach the plane. If you look this diagram, that the tension to upwards, this one, on particle B, while there is another force, m times g, acting on this particle, and the direction to downward, m times g, it means 5 kilograms times 10, so this is 50 Newton, acting on this one, on this particle B. Meanwhile, for particle A, the direction to upwards, and then also there's acting a force m times g, 3 times 10, 30 newtons. So it means I would like to find for m times A equal F1 minus F2. Okay. This is F1 and this is F2. So it means 8 times the acceleration we are going to find. This is 50 minus 30 equal 20 newtons. So it means A we can determine through 20 over 8, 2.5 meter per second square because acceleration. And let's find the tension on particle B. The tension on particle B we can find through mass of particle A times acceleration equal to tension on particle B minus 30 because 30 is the mass of uh, particle A. So, okay, mass m times g. I mean, okay, let's say m times g. This is W weight, and then it becomes 3 times 2.5 tension on B minus 30. So the tension on B becomes 7.5. So 7.5 plus 30. It is 37.5. This is the tension on particle B. And after that, you're going to find the time taken. The time taken, I'm going to using this formula that S equal UT plus 1/2 times AT squared. Okay. So S equal 2 because the distance, if you look at 2 meters on part B, particle on part B, the distance is 2 meters. Initial velocity, there is no initial velocity equals 0 plus 1/2 times 2.5 acceleration is squared. So it becomes, if you calculate this, is 1.25 t squared equal 2. So t squared equal 2 over 1.25. And the result is 1.6. So t squared equal 1.6. So it means t equals square root 1.6. Yeah. It's 1.6, not 16, 1.6. And if you find the solution, the number, the result is 1.2643. So on, I would like to round off, becomes 1.261. After that, part B, the next question. Find the time for which A is at least 3.25 meters above the plane. Right. I would like to sketch this condition because there is an extra explanation about this condition. Okay. If this is the ground, okay, and this is the particle P already here. So actually, the first position of particle A here is 1 meters. Okay. And if this is according to the information that is this is 2 meters, and it means the rest is 0.25 3.25 because according to this information that at least 3.25. If already 3.25, look that the first position of particle B is 2 meters. Okay, you look this one. I'm gonna show you 2 meters. Okay, 2 meters on this one. So it means if already 3.25, it means the particle be already in the ground, right? And you know, so when on this one on the 3.25, it will going to this particle will be going to until here, the maximum, and it will be going back again to downwards. It will, this is the maximum height of the particle A, right? So if we calculate, we need to find first the velocity of A when from this initial position to the last position. So I would like to using V equal U plus AT. Okay. This initial velocity equals 0, and then this is 2.5 times square root 1.6. This is T. And the result is 3.16 meter per second. This is the initial velocity of particle A. And after that, I would like to using this formula that distance equal ut plus 1/2 at squared. This is 0.25 distance, and the initial velocity is 3.16 t plus 1/2 times 2.5 t squared. So it becomes 0.25 3.16 t minus this is plus, oh, sorry. Actually, this is, I would like to using this is the gravitational force. Okay. So when the particle A goes upwards, it has the gravitational force -10 because opposite with the direction of the gravitational force to downwards. So it becomes minus 5t squared. So this equation becomes what I would like to find t minus t becomes positive 5t minus 3.16t, okay, plus 0.25 equals 0. So this is A, this is B, and this is C. T1, T2 using the algebraic quadratic formula 3.16 plus minus square root minus 3.16 squared minus 4 times 5 times 0.25 divided by 2 times 5. It becomes 3.16 plus minus square root. If you calculate this is 9.9856 minus 5 over 10. Let's scroll down first. Okay, so it becomes 3.16 plus minus 2.23284, so on, divided by 10. So T1 equal Scroll down again. T1 equal 3.16 plus 2.23284 for 10 equals 0.53928 on, and T2 equal 3.16 minus 2.23284 on, divided by 10, and the result is 0.09271, so on. Now, I will show you the time. Okay, right. This is the positions of particle A, right? From the ground, from the ground, this is B. Okay, from if this is the ground. Okay, so when the first time the particle A from this the initial position goes upwards, okay, it will be here the first time when t equals this one. When t equals 0.09271, the particle A position here the first time it was here, and after that it will be goes to the maximum high and then return back, and after that in this positions the time is this one 0.53928. This one. Okay, that's the meaning of T1 and T2. All right. Now we are going to find the durations as long as from this one to this one. So to here, so it means T1 minus T2 is 0.53928 on minus 0.09271 on, and the result is 0.44657 on off 0.447. This one.